Order, order. The Science, Innovation and Technology Committee is in session, and we continue this morning our inquiry into UK astronomy. We're very pleased to welcome our first pair of witnesses to help us with that. And joining us here in the room is David Arditti. Mr. Arditti is President of the British Astronomical Association and has been since 2021. He chairs the Sir Patrick Moore Prize Committee, which awards prizes to promote amateur astronomy, and he is an accomplished composer of contemporary classical music as well in his spare time. Joining us virtually is Professor Chris Lintott, who is Professor of Astrophysics and Citizen Science Lead at the Department of Physics at the University of Oxford. Professor Lintott is also an author and broadcaster, including the BBC's Sky at Night programme, and he's a member of the collaboration that's building the Veron Rubin Observatory in Chile, which will be equipped with an 8.2 metre diameter mirror and a 3,200 megapixel camera to create the widest and deepest and first ever 10-year movie of the night sky. Something to look forward to. Thank you very much indeed for joining us today. We're very interested this morning to talk about amateur astronomy and the contribution that it plays. And perhaps starting with Mr. Arditti, the President of the Association.
My correct title is Doctor.
Doctor.
Yes,
do forgive me.
Seems to have got lost.
Indeed. Well, that's I'm glad you corrected that. So, Dr. Arditti, I think there are 192 amateur astronomy societies across the UK, I'm told. So tell us a bit about the contribution that is made by amateur astronomy.
Well, amateur astronomy remains the only area of science in which amateurs make a really big contribution, and a serious contribution, and one that is important to the professional community. And the reason for that is quite obvious, that the sky is huge and professionals cannot monitor it all the time. Increasingly, they do have the capability to survey all the time, but only to a certain level of detail or a certain depth. So amateurs can study objects that, for one reason or another, are neglected. They're maybe not particularly fashionable for the sources of research funding at the moment, but they may become more important later, and it's important to keep these records going. Amateurs do that, and they also take part in projects that professionals coordinate, and that's a very important part of the BAA's work, is linking professionals with amateurs and coordinating projects on all kinds of different objects in the sky, the solar system objects, the objects further out in the universe, stars in our galaxy, variable stars in our galaxy, and more distant objects. So amateurs can do actually very sophisticated work. They can do things like spectroscopy, which is the splitting of the light from stars up into its component colours and analysing it. They can detect planets round other stars. They can confirm professional discoveries like supernovae, which are exploding stars in distant galaxies. And they also, at the more local level, we collaborate with, for example, NASA and ESA on monitoring the planets when they send probes to the planets. The probes typically look at a small area of the planet, or they can only look at, they're only there for a short time. We can provide a longer-term context because we have amateur observers all over the world, and we've been keeping records for a long time. We can tell them what the long-term weather is on Jupiter or Mars, for example. Helps them to put their more detailed discoveries from the probes into context. So there's always been this interrelationship and a lot of respect, I think, both ways. It always surprised me how egalitarian astronomy is. There's no sense or little sense of separation. The BAA arose because it's really separated off from the Royal Astronomical Society in the late 19th century, when astronomy started to become professionalised and there was a need for a society that catered for amateurs. But we've always had a certain number of professional astronomers in our ranks, and many of our members, if not, they're not professional astronomers, but they may be professional scientists in other fields, so they know what they're doing.
Very good. You mentioned that there are certain fields that are unfashionable for for research funding. Can you give us some examples of those that amateur astronomers pursue?
I would say, for example, meteors, the small bodies of the solar system which collide with the Earth frequently. Amateurs monitor exactly where they are, what times of the year they occur, and how they are changing. And they're associated with comets, and when comets disintegrate, they produce meteors. And these are fairly unpredictable phenomena. They're affected by subtle gravitational interactions between the solar system and all kinds of collision processes. So we keep track of these things. And comets as well. The orbits of comets are constantly changing. So amateur observations are very important to know where these things are, and also some of the small asteroids.
Why don't the professionals do that? Why is that the preserve of amateurs?
Because, well, you don't need big equipment to observe these things. A lot of it can be done with the naked eye, or with binoculars, or small telescopes. And so I would say there's more funding for slightly more glamorous areas, like looking at black holes, studying or the expansion of the universe. Chris may disagree or may comment on this, but I would say there are certain areas that are fashionable at the moment, and other areas less so. There's a thing called noctilucent clouds, which are on the border of the Earth's atmosphere and outer space, and we don't really know what causes them. And they've become much more common in recent years, and they may be linked to climate change, or they may be linked to space debris, which may be linked to human activity, or they may be linked to solar activity. But amateurs monitor this, and there is some professional activity in that area now. There is a specific satellite that's been looking at it from above, but it's really a thing that is not particularly on professional astronomers' radar. I would say it falls in the cracks between atmospheric science and space science.
Very good, thank you. Perhaps I can turn to Professor Lintott, and you're a professor at the University of Oxford. What is your interaction with amateur astronomers and people in your professional roles?
Sure. Well, I can add to what David's already said by pointing out that the Astronomical Society is that network across the country, which you mentioned at the very beginning of your question, doing really important work in terms of engagement with the broader public as well. And so I spend a lot of my time talking to amateur astronomical societies about projects like the Vera Rubin Observatory that you mentioned, as an effective way of communicating broadly. We're very lucky in astronomy that this network of enthusiasts contribute to the science, but also our cheerleaders and our representatives in their communities as well. And I think that's a valuable aspect of this amateur professional crossover that shouldn't be forgotten. I myself grew up in a local astronomical society and owe my interest into the efforts of the people running Torbay Astronomical Society several decades ago.
But about that, so how old were you when you first took an interest, and how did you find your local society?
Well, I was lucky that my school had access to an observatory, and took the slightly crazy decision to give a bunch of 11, 12-year-olds the keys to the observatory and encourage us to go and make our own observations. So I spent an awful lot of my evenings and most of the summer holidays working with the people from the society to try and make observations without too much success, I should say. It's not that we were doing groundbreaking research, but the thought that we might be able to was exciting. We did things like count meteors and even observe a few distant galaxies. But what's happened in the last 15 years really is that there's a new aspect to this collaboration, which is that the amount of data that we have from mostly professional observatories has exploded thanks to digital cameras and new technologies. And there's become a need to enlist not just amateur astronomers, but the general public, people who haven't thought about astronomy before as part of their lives, in sorting through that data to identify unusual objects and indeed just to classify everything from galaxies to planets. And so my main professional involvement has been building and running a platform called the Zooniverse, which was UK-led, but a collaboration with lots of partners in the US in particular, to produce a website where people can log on and contribute to science in just a few minutes. And so we've got this traditional form of amateur astronomy, which is monitoring the sky, which is still important. But we now have this new form of what's often called citizen science, pioneered in this country by astronomical collaborations, where we're inviting people to make use of the data that we've collected from the cosmos, and that's become increasingly important.
Very good. To tell us where we can find that website and the people tuning into this this
Sure.
hearing.
You can go to zooniverse.org and pick a project. It's now expanded to about 200 projects well beyond astronomy. To give you some idea of the scale, we've had over the 15 years or so we've been running the platform, we've had about 800 million contributions from about 2 million registered users. So this is an enormous amount of effort. One of the things that's been particularly important has been that when you ask members of the public to engage with a large data set, to look at images of distant galaxies, for example, you find that not only are they excellent at the tasks that we imagined they might do, dividing galaxies into their various types, but people are also wonderfully distractible. And so they find things that we weren't expecting in the data and ask questions that we weren't expecting. And so this form of engagement not just provides useful scientific data, but it expands the range of things that we're looking at and discoveries. It's been a great pleasure to do things like use the Hubble Space Telescope to follow up on discoveries made by individual members of the public via our projects.
We're going to go into a bit more detail with my colleagues. I'm going to turn to Rebecca Long-Bailey. But just before I do, perhaps I can ask the same question of Dr. Arditti. How did you get into astronomy?
I read a book by Patrick Moore in the school library. Patrick Moore was, of course, the presenter of The Sky at Night on BBC TV for many decades. And, of course, Professor Lintott has been a presenter on that as well, and Maggie as well. So that's really the classic route. And Patrick Moore was so important in inspiring so many young people of my generation to get into both amateur and professional astronomy. But also important was the fact that my father had a business friend who was in a local astronomical society. And so he took me along to one of their stargazing sessions, which was at the home of a member who had a big telescope by amateur standards. And at that time, for that time, it was a 12-inch diameter telescope. So it was about 6 feet long and a foot wide. And he had it in a home-built observatory in his back garden. And we looked at Saturn one evening in April, and I could see all the satellites of Saturn and the rings with amazing clarity. I'd seen them through a very small telescope, a 2-inch telescope before that, but I saw all that with amazing clarity, and we looked at other objects, and the people were just so open and so keen to explain everything, to share their knowledge, that then I joined the society. And the rest is history, really. I've been doing that ever since.
Now you're president of it, so
yes.
That's a lovely story. Thank you very much. Rebecca Long-Bailey and then James Davis.
Thank you. Dr. Arditti, my constituency, Salford, has its own astronomical society, and they've got their own observatory, which apparently was opened by Patrick Moore in the 1970s. And they've been doing fantastic work in the community, ensuring that astronomy is accessible to everyone in the same way that Professor Lintott and yourself have just described. But how healthy would you describe UK amateur astronomy, and how accessible is it to everyone in other parts of the country?
I think it's pretty healthy, and the local astronomical societies are really important because many of them are in small communities or isolated communities, but they organise meetings where they get leading experts to speak to them, and so they are an interface between the professionals, the universities, and the grassroots level, and ordinary people. And they will organise lots of events, typically maybe go into schools and show the kids telescopes, or how to make telescopes, for example, how to make simple observations. Youth groups like the Scouts, they have an astronomy badge, so often the members of local societies will help with that and help them to get their astronomy badge, to do simple things like identify the constellations. So this is all really important. And I think there certainly are problems of diversity in astronomy. I mean, that is established. In the BAA is very predominantly male, very predominantly white, and that's a thing that in my term as president, I've been keen to try and work out some of the reasons why that might be, and to see what we can do about it. I'm also in the West of London Astronomical Society, which is a local society of about 200 people, and that is in a very racially diverse area of West London, and I would say that is more racially diverse than the BAA is, and also much better balance of men and women. However, it's still probably not completely representative of the community. I think there is definitely an issue there, and I know the Royal Astronomical Society have studied this as well, and they've spoken to young professional astronomers and found that there are females still find considerable barriers to career progression. So I think it's not, from that point of view, it's not the best example of diversity.
In terms of other countries around the world and their amateur astronomy networks, how do we compare to them, and how do we compare to them in terms of funding and access to facilities?
Well, I have quite close contacts with societies in the United States and Germany, France. Yeah, they all have their strengths. They all have slightly different cultures. I would say we're very strong. I would say British astronomy and British amateur astronomy has always been very respected around the world. And our journal, well, our organisation, we have a lot of overseas members, and our journal is distributed around the world to libraries around the world. And we do allow amateurs from other organisations to contribute data to that. So you don't have to be a member of the BAA to have your observation, your data published by us. And that's very important that we do that, because then we can get the biggest amount of data and the biggest number of observers around the world involved, and we can publish better data. So getting away from that, how are we off for resources and compared to other countries? We don't have much for public astronomy in Britain apart from voluntary activity. There's not many planetariums or planetaria. There's not many public observatories. There's virtually none, actually. There's virtually no public observatories in Britain, and there's only about 3 planetariums for the whole country. Whereas if you look at Germany, there are a lot more local observatories that are funded by, I think they're funded by local government or regional government. They certainly have grants from somewhere, and they're probably staffed mainly by amateurs, but they are like hubs for community participation in astronomy and getting people interested in science. In a way, we don't really have that here. We've got the activities in schools and universities, and then we've got the completely voluntary things that are done on a shoestring by amateur societies, who some of them have their own observatories. They've bought land, or they've been given land and they've built something, and then they usually open up to the public to a certain extent. But it's all very shoestring. So I would say it's I would say there's less involvement from local and regional government in this kind of thing in the UK.
Thank you. And Professor Lintott,
Thank you. Yeah, I'll try and be brief because I know time's getting on. But I should mention I'm the honorary chair of the British Association of Planetaria, which has more than 50 members. So we have all sorts of scales of organisation involved. But I wanted to draw an example out of your own Salford Society, which I know well. I know them because they do an excellent job of engaging the community and have developed programs with local educational organisations as well. They're an example of what societies can do. But it's very interesting to me that the partnerships they've developed internationally have come from the US. They are partners with the Jet Propulsion Laboratory, and they use material developed by NASA for their purpose. And it's always a slight, I think it's a slight source of regret that it's harder in this country for us to support the kind of informal outreach that we've been talking about from our own research programs and from those of the European Space Agency. The funding that goes along with our research programs in professional astronomy and space science in this country only rarely include funds or support to develop materials for partners in the kind of informal education that we've been talking about. So that is one serious difference, I think, between what happens in this country and what happens particularly in the US.
Yeah, thank you. And you mentioned in terms of the relationship between amateur and professional astronomers in the UK, that a lot of amateur astronomers are enlisted to sort through large swathes of data. Now, in the case of Salford, they're doing some very specific research. So I just wondered how research was organised within the amateur field, or whether it was just a case of particular societies choosing what they wanted to research as and when.
So for people who are looking at the sky, who are using their own telescopes to make observations, there are international and national organisations like the BAA who take on a coordinating role, so that, as David mentioned, you can bring observations together. For the newer form of citizen science that I was talking about, those are mostly online projects, and people find them in their lunch breaks, in their spare time. And we deliberately design those projects so that you could very quickly make a contribution, so that perhaps somebody who hasn't been interested in astronomy before can go to the website and find themselves trying to discover a planet. We've found that authentic engagement, saying to somebody, not I'm very clever and I've discovered a planet, but together we can do this, is transformative. And that can be the spark that could really change somebody's attitude to science, or encourage them to do more, including making their own observations. So those things are usually coordinated online via Zooniverse or various space agencies or observatories.
Thank you. And how structured is coordination between local societies and local universities? So Salford's really lucky in the fact that it's next to Manchester University, Salford University and Manchester Metropolitan University, so they've got all of that on their doorstep, but other societies won't be in the same position. Is that support coordinated for them?
No, that's all local and ad hoc. It's very common to have the kind of relationship that you're talking about, but it really depends on the resources that the university has to put into its engagement as well.
Lovely, thank you.
Very good. Thank you very much. James Davis and Tracy Crouch wanted to come in, then Stephen Metcalfe.
Thank you, Chair. I wanted to raise the issue of light pollution and its impact on amateur astronomy. So light pollution both from space and from Earth. Firstly, Dr. Arditti, could you describe the nature and extent of light pollution that comes from space, including from satellites? And
we need to be quite tight on time, so if that's a big question, if you could give a summary answer to it, that would be...
Big question, and these are two quite different subjects, because ground-based light pollution, government and local authorities have the power to deal with that, whereas satellites is going to require international agreement, and it's an increasing problem, because the sky is going to be filled with small satellites which are put up for communication purposes. There's already the Starlink system. There's several thousand satellites have been put up recently, but projections are that with all the launches scheduled by China and India and Russia and Europe, there could be hundreds of thousands of satellites visible to the naked eye. These would completely change the aspect of the sky, so that the traditional sky as we know it, the constellations, would be almost obliterated by a constantly moving panoply, a tapestry of local lights moving backwards and forwards. So we really need urgent international action to try, and we're not going to stop this because there are powerful commercial drivers behind it, but moderate it. And I know certainly the professional astronomers through the International Astronomical Union are working hard to get this discussed at the level of United Nations committees and so forth. But going back to the more local level, in Britain, I think one thing I'd like this committee to emphasise when it reports is there are lots of problems with the control of light pollution in this country at the moment. It was brought under the Environment and Clean Neighbourhoods Act some years ago, that local authorities have some powers to regulate and take it into account under planning.
Yes.
However, there are very large gaps in that legislation. For example, all sports facilities are completely exempt. They can do whatever they like. Anything to do with transport is completely exempt. Anything to do with defence is completely exempt. So there are very large holes. So you can have as much lighting on a golf course as you want, or a sports stadium. Now, we're not asking for all the lights to be turned off, and let's be very clear about that. We're asking for sensible lighting at the times that it's needed and the places that it's needed, and to make it efficient and to eliminate the leakage into space as far as possible. And Britain has a relatively poor record on this.
We need to be a bit more concise, otherwise we're not going to get through the questions that we have. So, James?
Well, I'll move to Professor Lintott for his perspective on this, if that's okay. I mean, I know in my area, Clwydian Range and Dee Valley, there is a Dark Skies initiative. How successful are those being? We've also, in terms of satellite pollution, heard about the need for international agreements. Are there any other countries that are doing things differently to us to help achieve that?
I think the satellite issue is very difficult. There are international diplomacy underway at the UN, led via the International Astronomical Union, and I'd encourage everyone to investigate and look into those issues. This has to be solved internationally. I think your point about the dark sky parks is interesting. Lots of parts of the country, from Dumfries and Galloway down to Exmoor and the Channel Islands and many places in between, have found that dark skies is a way of promoting tourism and interest in an area. Those are community-supported efforts, and they've been very effective. Of course, the moment you introduce large numbers of low Earth satellites, then you lose the joy of a dark sky. And I think we should remember that for most people in the country, their nearest wilderness is space. It's just above their head. And we have a right, I think, to enjoy a reasonably unfettered view of the night sky, which is transformative for many people. And we are at risk of losing that view forever in the next 10 years if there isn't urgent action.
Right, so a very big challenge. Thank you.
Thank you very much. Tracy Crouch and then Stephen Metcalfe.
Very brief question based on replies to an earlier question. I just wondered, how much does it cost on average to be an amateur astronomer?
Is that to...
Perhaps Dr.
How long is a piece of string? Yeah, you can do lots of useful work just with the naked eye, monitoring meteor showers or looking at some of the brighter variable stars. Yes, I wouldn't say it's the most expensive hobby. I'm sure you can race yachts or do much more expensive things. And indeed, it's got cheaper in a sense because the equipment is now mass manufactured, mainly in China. When I bought my first telescope, which was a 6-inch diameter telescope in 1982, it cost £150. Today, if you want to buy a 6-inch telescope, it costs £250. It costs almost the same now as it did then in absolute money. So, and it would be better as well today. So you don't have to spend a tremendous amount. And the BAA actually offers grants to amateurs if we think they've got a good idea for a research project and they need the money to buy equipment, telescopes, cameras, filters, various things, then we can give them money. I think that's not the main problem people have in participation. I think perhaps time is a bigger factor.
Thank you.
I will add only that the advent of open data and the free sharing of images from space missions and from observatories mean that it's very easy to be a fan of astronomy online, and the projects that we put together mean that it's open to all to contribute. So I think we have been deliberately lowering the barriers to access things like images from missions to Mars and so on.
Good. Thank you very much. Stephen Metcalfe, then Graham Stringer.
Thank you very much indeed. Professor Lintott, you talked about the Zooniverse, which was very helpful and very interesting. Thank you very much for enlightening us on that. Are there any particular skills or expertise that citizens need to be able to take part in these citizen science projects?
Yeah, it's an excellent question on which I threatened your clerks that I had a 3.5-hour lecture on, but I shall spare you that. The projects are often designed so that anyone can take part, so that really you need a web browser and a few minutes training. But what's interesting, I think, is that we see many citizen scientists, many volunteers, some of them with amateur astronomy backgrounds, some coming in cold, developing skills over the course of these projects. So I'm thinking, for example, of a misbehaving star known as Beauregin star, which was spotted by volunteers on our Planet Hunters project. This is a star that dimmed suddenly and unexpectedly, and then came back to full brightness, and then started blinking as if somebody was fiddling with a dimmer switch, completely unexpectedly. This was a mysterious object, but before the professionals in the project could get to it, our volunteers online had developed their own model and hypothesis involving a dust disk around the star, which was blocking out the light. It was a publishable work. And so what we see is that these projects provide opportunity for skill development. And indeed, we've got some evidence that those who've developed skills through these projects go on to use those skills, for example, programming or data analytics skills in their workplace. So we do see these projects as a way of contributing to upskilling the workforce, and we're looking at developing programs, for example, for schools, but also for informal education, where we can use these projects and the motivation they provide to people to develop these skills to pick up things that would be useful elsewhere.
Brilliant. Thank you very much. Dr. Arditti, do your members, I mean, you've obviously talked about the important role the BAA has and your members and the contribution they make. Do they take part in the citizen science projects as well? Or?
Yes, many of them do. There are many types of citizen science projects. There are the type that Chris has organised with his Zooniverse project, where all the data comes from professional telescopes and then amateurs are sifting through it. There are other types where there's a project at the moment called the ExoClock project, which is to do with ESA, and that's a satellite which is going up to look at planets of other stars and when they measuring their properties, and professionals need to keep their orbits under review, and many of these orbits can be timed. The dimming of the star as the planet goes in front of it can be timed with small telescopes. So that is a citizen science project, is a project coordinated by professional astronomers in universities, which amateurs feed data into, which is gained from small telescopes or maybe bigger telescopes that they can hire from time to time. So, and the BAA, yes, does give a lot of help with that, a lot of coordination, and it's one of our main raison d'etres. We are organised into sections for each area of astronomy. We have a variable star section and one that deals with the exoplanets, and we have more experienced members will tutor the beginners in the techniques required.
Excellent. So I touched on my next question, which was really about do your members, do the BAA promote citizen science? And is there a sort of a role for you in that? And are you resourced enough to be able to carry out that role?
I think we promote it to a certain extent. But we don't have to. I mean, we don't have to do what anybody else wants to, because we're so if our members want to do something else, then we do what they want. But yes, we have a lot of meetings where the people like Chris will talk to us and explain what they want to do, and we'll try and find people who want to take part in those projects.
Okay, thank you. And the last question is. So yesterday, my 5-year-old granddaughter, Daisy, asked out of the blue, how old are planets?
How old?
How old are planets? Yeah. Now, that's not actually the question. The question is, I then went to, I thought it was the Earth is about 4 to 4.5 billion years old. I happen to know that. But what I was going to ask you is, I then went to look for resources that you could provide to a Key Stage 1 student to help them get enthusiastic about astronomy and understanding the universe. And I just wondered what role the BAA and you, Professor Lintott, have in providing resources that educators can use that makes this subject acceptable and gets people excited about it, who become your members in the future and who become professors of astrophysics in about 20 years' time. Do you think you have a role in that space? And if so, how do you fulfill it? So who shall I start with? Dr.
I think we ought to. I think we haven't done enough of it, and as President I've been keen to push that. We've just taken a decision to set up an education section. We've been taking part in the astronomy, in the New Scientist Live show, which occurs every year at Excel in London, organised by New Scientist magazine, and that has, I think it had about 6,000 school children through on one day last year. They had a day entirely for children, and we had our telescopes set up, and we had models of the planets suspended from distant parts of the hall, and we showed the planets to hundreds of kids. We've got we don't have much on our published directly aimed at children. NASA has quite a lot that is suitable for the early learning stages, I think we need to do more.
Thank you, Professor Lintott.
Yeah, this is very important, especially as we know that attitudes to science are set at an early age. And so if you wait till you're talking careers with sixth formers, then you have in some sense lost your audience already. I think we're good at engaging through universities. The research councils, and particularly STFC, have an excellent scheme for public engagement, which focuses particularly on exactly the early age groups that you're talking about, as well as underserved groups. And the universities in the UK, many of which invest heavily in astronomy, are good at utilising that funding. So I think in any locality, you'd find local schemes. What those schemes don't provide is central resources that could be used by anyone and which could be picked up by people outside the university sector, by our friends in planetaria, in local societies, and the informal network of astronomy educators. An example would be our Vera Rubin Observatory, which is a international effort, but very well supported in the UK and funded by the Research Council as a programme of importance. We added in our application some modest funds for public engagement so that we could develop exactly this sort of central resource. And that was de-scoped as not being important to the project. And so it was disappointing to see that the Research Council didn't consider engaging the public with this research effort as a core part of what we were trying to do. To me, the act of research goes hand in hand with communicating it. And I think if we looked at a system such as used to exist, I'm sorry to always be pointing to the US, but NASA used to have a system where a tiny percentage of any grant had to go towards the provision of engagement. And that was a good way of ensuring that there were indeed resources online. I should add, by the way, that I would, and on that theme, I'd point, NASA have a website called Space is the Place, and that's where I'd point your inquisitive 5-year-old.
Yeah. Thank you very much.
Thank you, Stephen. Graham Stringer.
Can I take you back to your answers to Becky's questions? You mentioned public observatories. Can you give us a definition of what a public observatory would be? And would it include Jodrell Bank, which is open to the public, for instance?
I would say so, yes. I would say it would be any observatory that spends some time just opening itself up and educating the public.
I mean, I could talk a little to Jodrell Bank because I know that group well, and I think their recent elevation to UNESCO World Heritage Site status has stimulated a huge amount of activity, and the new visitors centre there is a marvel. I encourage anyone who hasn't gone to see it to do so. It tells both the science and the history of the site brilliantly. There are other large-scale efforts nationwide as well. I was just talking to the team behind the Sherwood Observatory, which is a £5 million development in Nottinghamshire, which will include a planetarium and visitors centre. But there are informal places around the country where societies or other groups, universities, can open up their observatories to the public. And the most important thing, I think, is to get people to look through a telescope at Saturn or the Moon. Those are the two things which really stun a first-time viewer. And those can be life-changing and inspiring events. And so, as David says, there's this tradition of a public observatory, but what we have really is rather than a set of museums that do that, we have a set of institutions that are willing, through volunteer support, to give that opportunity to people.
Thank you. In our briefing notes, we've got a couple of comments saying that a lot of citizen science is absolutely excellent, first rate, but sometimes it falls down. Sometimes there are breaks in the statistical analysis or the observation. As a committee, we've also looked at a lot of professional science, the problems of replication and other issues, and basically scientists, like other parts of society, cheat. So is it a problem, the quality of science from citizen scientists, and what are the impacts of that? Are there any checks on it? If I can ask you both that question.
Well,
sure, I can start a bit. Yeah. So on our side, the Zooniverse projects, because we have several people look at each image or each data point, then we're able to cross-check and validate, and we have no problems with people submitting false data or so on. But it is, of course, like any carefully designed experiment, something we go to great lengths to validate statistically. On the observing side, David can say more, but again, because we're working in networks of amateur astronomers, the sort of cross-checking that one is able to do produces data of high quality. And unlike in, for example, biological citizen science, where often you have people out sampling their local river for water quality or monitoring their local environment, where you may be the only person doing those measurements, and it's harder to cross-check because the sky is open and can be observed from all over. In many cases in astronomy, we are able to escape the worst of this replication crisis.
Well, the falsification of data is not unknown in amateur astronomy as any area, but there isn't much incentive for it, really. And the checking takes informal and more formal forms. So because, for example, I'm working and constantly looking at the images of Jupiter, for example, produced by other amateurs, and I'm taking images of Jupiter myself, we know what it should look like, and it's very easy to spot somebody who's processed their images wrongly or exaggerated certain features in a way that is unrealistic. We informally, we know what good data looks like, and then when stuff is published, it is peer-reviewed in our journal, so we get either professionals or experienced amateurs to look at it, and this is accepted by worldwide as being authoritative. So I think there's never been a major problem with this. It's like in any field, humans are fallible, but the checking is as good as it can be, and if we find something is wrong, then we'll issue correction later. But it's important to realise that this vast amount of data is very largely correct, and even observations of variable stars with the naked eye, you can get to a tenth of a magnitude accuracy, which is like a few percent accuracy in just estimating the brightnesses of stars with the naked eye, just by comparing the brightness of one star with another. And believe it or not, although that sounds like a subjective process, because we got hundreds of observers all around the world doing a similar process, and we plot them in a graph, and we can see where the outliers are, and we can compare that with the best professional electronic measurements, and we know what the errors are. And so, yeah, the data is, in general, very robust, I would say.
Just finish with a comment following up on what Becky was saying about amateur astronomers in Salford. In my bit of Salford, we both represent Salford, is Crabtree's cottage where he first measured the transit of Venus in 1639, which of course led to an improvement in Kepler's tables, which led directly Kepler's work to Newton's Principia, which is probably the most significant scientific treatise ever. So it's a wonderful example of amateur science going back a long time.
Without Salford, we wouldn't have had...
Well, precisely.
Okay.
Yeah.
Thank you. We'll finish with James Davis.
Yes, I think we have 1 or 2 minutes only in this panel. So, Professor Lintott, in terms of citizen science, what opportunities does it offer for people to move from the amateur stage up to something more significant?
Yes, we're seeing an increasing number of applicants, particularly for example, for our PhD programs, have citizen science experience, albeit often alongside a university degree, particularly several excellent applicants who've done, for example, open university degrees later in life. I think it provides opportunity for skill development that I've talked about. Yes. And we're also working hard to find opportunities for citizen scientists to publish their work as well, either in the main astronomical journals or in specialist publications, so that they have a track record. So I think it is an opportunity for people to get a sense of research and to use that perhaps as a career step. I wouldn't want to suggest that that most of our participants are interested in changing career. Most of them are interested in making a contribution with the time that they have available. But for those who want to do more, it's clearly a useful step towards getting a sense of what being a professional astronomer or a professional scientist is like.
Yeah, so finally, do you think academic institutions other than your own could be doing more to assist that transition where it's valuable?
Yeah, I think there's clearly a need for something halfway between I am somebody who's a serious amateur astronomer or somebody with a serious interest and somebody who's embarked on a full-time career. And I think you see that in demand for the kind of distance learning courses that many institutions provide in astronomy in particular. And so I think there is this untapped demand and need that I think perhaps universities could be better at responding to.
Okay, thank you.
Thank you very much indeed, James. Thank you, Professor Lintott, and thank you, Dr. Arditti, for your evidence this morning. We're now going to invite our next pair of witnesses to join us at the table. As they take their seats, I will introduce them, and we're very pleased to have Dame Maggie Aderin-Pocock, who is an honorary research associate at the University College London Department of Physics and Astronomy. She's been the Chancellor of the University of Leicester since March of this year, and since February 2014, in other words, over a decade, she's co-presented the long-running television programme The Sky at Night. And in 2020, she was awarded the Institute of Physics William Thomson Lord Kelvin Medal and Prize for Public Engagement in Physics. Thank you so much for coming, and Dame Maggie's also been President of the British Science Association. Joining her here at the table is Chaz Bishop. Mr. Bishop is the Chief Executive of the National Space Centre and is a trustee of the Association for Science and Discovery Centres. Thank you very much, both of you, for coming. You've caught a bit of the previous discussion, and perhaps I could start with Dame Maggie. You present and followed in a very important tradition of broadcasting on astronomy. How important is that outreach in television, in your case, to generating the interest in citizen science that we've heard about?
Sorry, could I just make a correction? I don't actually work at UCL. I actually run my own company, Science Innovation Limited, and through that I do sort of extensive outreach. So over the last 20 years, I've spoken to 500,000 people, sort of direct. But so yes, I do lots of outreach.
I beg your pardon.
No, please. I think television and also direct contact is critical in terms of getting aspiration. I like to call it the desire to aspire. Because one of the challenges we face is we were talking about sort of science communication and sort of citizen science and things like that. Sometimes it's to the usual audience. So I think previously it was mentioned that sort of people go to New Scientist Live and things like that, but that attracts a certain audience who already have an interest in the subject. Where television and outreach at schools and things like that transcend that is you're speaking to everyone. And so I've been very lucky. I do this at night, but I've done a number of programs like CBB Stargazing, which is stargazing for sort of 5 to 7 year olds. And we sit in a cold field in Derbyshire and say, imagine what you'd see if the clouds weren't there. But, but I've met sort of many kids who say, oh, yes, you're Dr. Maggie, and I've seen you on TV. And so it is just like an introduction. Also, it's a powerful introduction because I think space and astronomy, the kids just love it. I write children's books, and one of the things I'd love to do is write a children's book about space and dinosaurs, because then I've got the market. Because these are things that kids are fascinated with. And so I think that's why television, especially, is critical for this, because it is reaching a very general audience and not a pre-selected audience, which is often the problem we have otherwise.
And in terms of the children's programmes, to commission that programme, did you, as it were, sort of cause it to be commissioned? Did you kind of suggest it to them, or did the BBC wisely think that this would be a good thing to commission to be broadcast?
Yes. And so I was approached for both of those, for the children's programmes, and I have sort of tried to lob ideas in there in the past. Children's television is an interesting area, sort of area with, I would say, underfunded, and so getting new children's programmes commissioned is quite challenging. Although my daughter and I, during lockdown, did do a programme called Out of This World from our kitchen, so with a very large green screen. So, yes, a few things, but again, I was approached for that. And so getting ideas out there can be challenging.
Do you happen to know, you say you were approached by, was it the BBC or was it an independent production company that...
I'm trying to think. So I think for CBB Stargazing, it was actually internal BBC. For Out of This World, for instance, it was an external company who asked if I'd be happy to sort of, and actually participate in sort of the layout of the programme. And then that was put to the BBC in this case and then commissioned.
Good. Let me turn to my colleagues, starting with Tracy Crouch.
Well, Dr. Maggie, I've seen you on TV too. I have an 8-year-old, and just as an aside, he goes to a church school and had a very difficult question relating to God, space, and dinosaurs. So if you could actually do the whole thing, but actually, and it follows on from my colleague's question about his granddaughter. There's a saying in sport, which is my background, that is, if you get a kid interested in PE at primary school, you'll have them interested in sport for the rest of their life. The same is true for science, and therefore my question is very much around, starting with you, Mr. Bishop, about what role do you play in terms of engaging school children on astronomy, and how does that role then raise an interest in STEM more generally?
Yeah. Yes, thank you very much. There's a network of about 60 science and discovery centres across the UK, so access is really important. They're in cities, rural areas. It's really important that people feel as though they've got someone local to them. Transport and access remains a problem, so most science centres will have a community programme or an outreach programme to make sure they can get beyond their natural catchment. What science and discovery centres are really good at is taking a difficult subject such as astronomy and presenting it to audiences in a way that they can understand and appreciate. And we're talking about audiences who, from one end, have no understanding whatsoever of the subject, quite literally, and that's often the parents, not necessarily the children, through to the experts who we see. Majority of our audiences are families with children aged up to 13, and to answer the previous points that have been raised, preschool is absolutely critical. So we make sure there's a lot of provision for preschool. We tend to aim a lot of our programming towards that sort of 11, 12, 13-year-olds on the basis that younger children want to be 11, 12, 13-year-olds don't necessarily want to be younger. So really exciting, engaging content for that age group is critical. In addition to that, most science centres, certainly the National Space Centre in Leicester, will have a schools programme which supports the curriculum being taught in schools. And again, for the younger children, you're looking to get them excited, you're looking to engage them in a topic, they've got to have fun, there's no question of that. And then as they move up through the age range to upper primary and lower secondary, you might start to try and help with their confidence in the classroom and their attainment. And then there are some science centres who have the resources to then look at older children and look at pathways into further and higher education, into the world of work, which I can talk about a bit more.
It's really interesting, but that requires a school to come to the centre. Right? It's very much a sort of kind of, the educators come to the experts. And actually what I'm really interested to learn is how do you get the experts shaping the curriculum into that easy bite-sized way for the educators to then deliver, to develop that thirst and that interest to then come to the centres. So let me reshape the question, and Dame Maggie, please feel free to come in, is what role are you playing in terms of shaping the curriculum, particularly for Key Stage 1 and Key Stage 2 children, not just relying on a teacher with an interest to book a coach, get 30 kids on it and come to you for 3 hours to learn about it?
Yeah, the relationship between the expertise we have, academia nationwide, and teachers is critical. Teachers are, on the whole, brilliant at driving the agenda and inviting us to go and see them. So we've got a lot of teacher panels, a lot of our curriculum subjects, where we talk to them about what they want of a science centre, what they want of the National Space Centre, and how can we help in the way that you suggest. And as you say, access is a really challenging one at the moment for a lot of schools. The coach journey is far more expensive than the entry to the National Space Centre. So we do a lot of community engagement programs where we will go out to the school, or we will go into community venues, be that libraries or social clubs, sports clubs, whatever it might be, and go to areas where people might not have the means, transport or confidence to come and see us. So we take our stuff to them, and it's really powerful and impactful. Evaluating all the programs that we do, working with teachers, yes, getting feedback from the students themselves is great, but the teacher feedback is pretty reliable, because they will tell us very honestly what does and doesn't work and how we can help with our expertise to influence the curriculum and introduce astronomy and space more generally as a teaching context for science subjects, which, as Maggie says, it's space and dinosaurs, there are others, where you just want a touchstone, you want something inspiring to get them interested and to introduce scientific subjects. And space is just a fantastic way of doing that.
So looking at various things, you sort of mentioned the curriculum and also sort of taking kids to the venues. I mentioned I sort of spent a lot of time going out to schools and speaking to kids. And it's just as Chaz says, it's trying to find the right hooks. So a few weeks ago I was making space ice cream on Blue Peter. It didn't have much to do with space, but they really liked the idea of the ice cream, and then that led on. So it's getting those hooks and getting those windows. One of the other things that I've been involved in, and I know quite a few universities are, is actually training our scientists, our researchers, to be effective when they go out to schools. When I first started going out and doing science communication, I was told, well, be careful, because last time we had a physicist come out, the number of physicists who wanted to take up physics sort of went down. So just sending sort of researchers out into the crowd, I don't think is a good idea. But for instance, I worked with the Royal Society doing sort of media training and also sort of training for scientists, so that when they get into a school or get into a circumstance or being interviewed on the Today programme, they are more effective. On top of that, one of the things I've been involved in the past is CPD, sorry, dyslexic, CPD, so training teachers and leading them and sort of giving them resources so they can actually access things that the European Space Agency is doing, things that NASA is doing. There is a wealth of information out there, but it is sort of, if you're not familiar with the field, it might be quite hard to find it. And so I think better resources, so that when you're doing a topic on, I don't know, forces in school, there is sort of NASA and ESA sites that you can say, oh yes, well this is relevant. So I've taken various notes. So yeah, going out to schools. one of the interesting things I think at the moment is that it isn't just about sort of TV and sort of going out. I have a 14-year-old daughter, and we watch TikTok together. Mm-hmm. And now on TikTok is sort of lots of kittens and things like that, but there were quite a few resources there where people are rapping and sort of talking about all sorts of... my daughter knows pi to I don't know how many digits because of a song she learned on TikTok. Mm-hmm. So there were quite a few resources there. And because that's what that sort of age group is watching, it makes sense to sort of utilise that. And I think as Chancellor of the University of Leicester, we sort of post things on TikTok quite a bit because we know that's where it's at.
Well, you actually briefly mentioned something that sort of answers the next question about how do we gauge and evaluate the success of communication and engagement in astronomy, especially in its ability to inspire future astronomers. But clearly, it doesn't necessarily mean sending out physicists. But what is it that, how do we gauge the success of the communication?
I started my career in communication about 20 years ago with some funding from STFC. It was, I think, PPARC then. It's gone through another number of iterations. And one of the things that we were very keen on doing is doing evaluation. And so often what we'd do is before I would do a session in a school, we would do questionnaires just to see, get a feel of their feelings about science and scientists and things like that. And then maybe a week later after the talk, we'd do sort of another evaluation. A few times we have tried to do sort of vertical, sort of over sort of longitudinal, so over longer periods of time, but they get to be very, very challenging. And so I think some evaluation is always done with most of the science communication is done, especially through organisations under the auspices of UKRI and all the sort of sister organisations underneath that. So that is part of getting the funding. But generally speaking, it is quite hard. So, for instance, I go to lots of literature festivals and give talks there, but there's no evaluation apart from anecdotal during the book signing and things like that. So it's quite hard to measure. I don't know, Chancellor, if it's easier for you because you actually have the people there, and so you can do before and after.
Yeah, what tools do you use to assess?
As Maggie said, I think questionnaires before they students start the programme, and then immediately afterwards, and then 3 or 6 months afterwards, you're trying to ascertain whether the knowledge has stuck, or whether that confidence in the classroom has stuck, or whether their attainment in the classroom has improved. As I say, the teacher feedback is possibly more reliable sometimes than the children who are responding to the enjoyment of the occasion, and the teachers are able to give really good feedback. And as I say, that if we have teacher panels, influences how the programmes evolve over time, because they will say what works and what doesn't work. Longitudinal study is brilliant if you can do it. And I'll just give an example of the work of the National Space Academy, which has a space engineering course it runs with Loughborough College. So this is a post-16 course where we take children, no family history of higher education, probably more confident in their vocational skills than their academic skills. But we take them for A-levels in maths and physics and a BTEC level 3 in engineering. So it's tough. And their expectation of their academic success is not particularly high. But we then track them through the course. They graduate and move on into wherever they want to move on into. The success rate of putting those students into higher education, whether it's degree course, degree apprenticeship course, 90% compared to 86% in public schools, and I think the comprehensive number is something like 81 or 82%. So it works. We then track them through university into the world of work. We've now got 10 years' worth of data to show what's happened, and they're going on into Rolls-Royce, Airbus, BAE Systems, some really high-quality people going through. And then you're looking back to see where the influences might be. There's a study just come out, there's something called the Space Skills Alliance, which is well worth getting to know some of the data they're putting out. They've just done a study that said 42% of people were influenced by a careers conference that they had back in school days. So that has really influenced what we do with our careers conferences, with space camps, as I say, multiple interventions. And I think what Maggie, you were hinting at, if you see students over half a dozen times or more, you get to build up a knowledge of them, and then you can start influencing course and career thoughts and giving them a pathway that might be suitable for them.
Thank you.
Thank you very much indeed. Dawn Butler and then Carol Monaghan.
Thank you, Chair. Thank you both. Dr. Maggie, I think you're incredible. I remember when I saw you the first time I saw you on telly, I thought, oh my goodness, you've really brought the subject to life, and it was just so engaging and infectious. And I just wonder, how do we compare? The UK always likes to say we're world leading. How do we compare to how other countries engage?
Yes. So it's quite interesting because in terms of engagement, we do a good job, but it's just as Chris was saying and in the previous session, there are resources, but it's getting access to them. And so I think we're talking about sort of telescopes. If you look at somewhere like America, there is a number of telescopes, observatories, many through philanthropic adventures, so putting a telescope up, putting a planetarium up. And I don't think we're quite there in that respect. But in terms of, I think we're pretty good in trying to actually get our scientists out into schools. There are a number of different organisations, STEM ambassadors, getting researchers actually out into schools. What makes it more effective is if we train the researchers first before they go out. Of course, I would like to see more. In an anecdotal way, one of the things I find is we need more role models. And we'll go on to diversity, I know, in a little bit, but we do need more role models out there. And one of the things I find is sometimes people come up to me and say, oh, we've named one of our lab at school after you. And I think that's wonderful. And I'm so touched. But we need more people to name labs after. So, yes. And so I think by getting more and encouraging scientists to think, yes, I can go out to the school. And it is quite terrifying at first. I do remember. But getting more people to do that, I think, just makes it more effective. So we are pretty good. But I think we need a better infrastructure. We need it more joined up. And I think other countries do that better. Also, to me, it's also a bit of a PR problem. Now, this is sort of astronomy and STEM. But if you take somewhere like Germany, when they speak about an engineer, they think of someone as a professional. Whereas in the UK, when you think of someone engineer, you think of someone with having a spanner and wearing overalls. Yes. And so this is a perception, which I think we are still trying to tackle, but I don't think we're there yet. But again, getting getting people to realise what engineers do would be a big step in that direction.
Thank you. And Chaz, do you agree? And what would be the three things that you would say to this committee? This is what you need to say to the government to give us.
Yeah. Well, I'd complement that answer, talking about France and the success of the space cluster at Toulouse, which is a very successful, huge campus. Lots of organisations there, but with public access at its heart. And I think sometimes we need to work harder at celebrating some of these clusters. Leicester is being influenced quite heavily by Cité de l'Espace, which is the public angle to Toulouse, it's now called Space City, the part of the world I sit. You're my next door neighbour, Maggie, at Space Park. So Space City, National Space Centre at its heart, the University of Leicester's new space camp to its north, and the City Council's Innovation and Grow On Space to its south. One of the original reasons, and there's a consistency here between Toulouse and Leicester, is regenerating brownfield sites which couldn't have been used for anything else. It's an old sewage works. Space Centre in the middle, there's now 100 organisations, space and science related, around it. Now think of the inspiration of having public access there, coming onto site, let's say preschool to postdoc is a sort of trope we use, but coming onto site and having sight of where their career might take them in the future if they take an interest, if we can introduce them. Role models, Exhibit A here. Maggie's talked a number of occasions up on stage with us at the National Space Centre, as Chris has, as others have as well. It's fantastic when you can put role models on stage and introduce them to students. But on that pathway to say, look, if these are the sorts of things you might do at school, these are the sorts of experiences you might do through further and higher education, and these are the sorts of places you might work. So as I say, I would say Toulouse is a really good example, and it's heavily influencing what we're doing in Leicester.
Thank you. And
yes, I think awareness is critical. speaking to sort of people, many people aren't aware that we do space in the UK. They think of space, they think of astronomy, they think of NASA. And so the fact that we are doing many, many missions, we're sort of batting above our weight here in the UK, is, and it appears on the news sometimes. So, for instance, on the way in, someone from the Today programme said, "Can you come and do an interview?" "No, I'm doing a select committee." So it's nice to get it out on the news, but kids aren't really getting that. And so celebrating the successes that we have, failures too, because it's all part of the scientific process, but letting them know that we're doing it here, I think, is so critical. And finding ways, a PR campaign, whatever, but finding ways of getting that out there would really help, I think.
Thank you. And just finally, how much, like, what would be the initial amount that you say, well, we need an extra, how much?
I could put a figure on the sort of money that the Science Centre network would very much like to do something you're not asking me to do, which is to talk about the ageing of our buildings, because we were hit very hard by the pandemic. It wiped out our reserves, and those reserves were being used to do the very charitable aspects of what we're doing. So free provision for those in disadvantaged communities, in the halo of the National Space Centre in Leicester, all the other science centres around the country. That's been squeezed a little bit because we've had to come back from the pandemic with the nuts and bolts of maintaining buildings, doing the commercial stuff, which is making us sustainable. So the figure there is about 50 million quid. It would be lovely, thank you, if that allows us to mend the roof whilst we are investing in these community engagement programmes. Those programmes, we're investing between £125,000 or £250,000, depending on how good the year is, on free provision for those who haven't got the means or confidence to come and see us. So as I said earlier, we go and see them with kit. In terms of success that Maggie was talking about, we're at 330,000 visitors at the moment, and we're capping numbers on a daily basis because we can't cope. Now, that's on the one hand, that's great. That means that the National Space Centre experience is great fun and engaging, what have you. But that is an indication of how exciting space is at the moment, and it's a lovely story to tell because it keeps evolving. There's always new stories to tell. There are always new researchers to come and talk to us or to put on stage, or, as I say, new stories, whether that's, we're talking about astronomy here today. I would say actually our gateway topic into the subject is human spaceflight, but then the astronomy tends to proliferate when we're talking about curriculum-focused study because that's more relevant as a context for teaching science. Human spaceflight's a really important part of it, though.
Thank you both very much.
Thank you very much indeed. Carol Monaghan. Thank you, Chair.
Dame Maggie, you're inspiring us even as we sit here. Two of us are sitting trying to work out 20 digits of pi here. But anyway, we'll try and focus on astronomy. We've taken evidence that tells us that astronomy, like many areas of STEM, is not particularly diverse. Now, you've talked about the importance of going into schools and how that can have an impact. Are there other things that you would choose to prioritise if you were in charge and had the funding that Dawn was talking about?
So I see this challenge as a two-way trend because in the past there has been external forces. So, people like you don't do space and astronomy and things like that. And I think we've made progress in that, in terms of gender, in terms of ethnicity, in terms of a whole range of things. There has been progress. But I think society is still dictating the internal pressure, where I don't see myself as that. And so, as you need to see it to be it. And if they don't see themselves in certain roles, then they don't aspire to do those roles. And so it's trying to break down those stereotypes wherever possible. And that's why I'm always harping on about a PR campaign. But it is a ways of getting exposure. Also, one of the things I've found is that it's just trying to show the diversity of things you could do with a career in space, with a career in astronomy. When I was growing up, for instance, I was born here, but my father was from Nigeria. And I remember it was quite a tough day when I had to tell him I was going to study physics rather than going into sort of medicine or law or things like that, because that's the pipe dream. That's what you do. And so with physics, physics is the study of everything in the universe, from the tiniest particles to the cosmos. And so, what are you going to do with that? And so it is showing what you can do with these sort of subjects. For instance, as a space scientist and an astronomer, most of the work I've done has been building satellites to look at climate change. Kids latch onto that. Through my work, I can make a difference. But
the problem is there's only one of you.
Oh, yes.
And that is, unless we can clone you and get you everywhere.
You don't want
yes,
one Maggie is definitely enough.
But it is a serious issue because we talked about role models this morning. We've talked about, the importance of being able to reach out to children when they're very young. It's very difficult for you to do all of that. How do we reach some of these communities that possibly aren't on CBBS, that possibly aren't going to Leicester to the Space Centre, that possibly aren't been taken to New Scientist Live? It's that kind of, there's a difficulty there.
Yes, and that's why I see that's why I see it more as a PR campaign and things like on TikTok, on where the kids go, and so because it is lovely that we we do science festivals and things like that, and but it is people who are already sort of that way inclined. But if it should the government have a role in that? Should they be putting stuff out on TikTok? And I think they could.
Oh, that's right, we don't do TikTok.
Yeah, big no.
Not allowed to do TikTok.
I think we should be encouraging universities to do TikTok.
Yeah.
And so it is sort of naturally getting out there. But I think it's more than that. A few years ago, I had this crazy idea that on something like EastEnders, you have sort of a group of scientists or astronomers move in, and so it becomes the everyday. Yeah. At the moment, it is a siloed. It's all those scientists, they're out there, they're not like us. It still seems
quite elitist. I mean, my daughter's 16 and she's very bright and very scientific and she likes astronomy, and she said to me, do you think I could possibly make it as an astronomer? And it was a negative kind of, it's against too unattainable. Yes. And I wonder, and that's someone that's been I'm a physicist, has been brought up in a physics household, and that is still perpetuating. And that I found quite depressing, actually. And I thought, how could we have made that any better?
Yes.
But maybe it does need something more normal, or normalisation of this.
I think so, because at the moment it is still, as you say, elite. It is only special people do this. People with a brain the size of small planets. And it's so trying to say, no. If you have an interest and a passion, then you can do this too. Of course, you need a certain aptitude for it, but also, there was this idea that sort of to be sort of work in astronomy or to work in space, you need sort of degrees, PhDs, sort of mount up all the there's apprenticeships. There's all sorts of ways of doing this, but people don't know about it. They don't know that there's a space industry. They don't know there's careers in astronomy, and they don't know what they need to actually work in these careers. And so, I think relying on careers officers in schools is they're covering everything. They can't cover everything.
Don't have the specialist knowledge.
Yes, and so, but I think if we make it part of the de rigueur, the everyday, then people think, space scientist isn't something weird and special. It's something that normal people do, relatively normal.
Thank you. And if I turn to Chaz now, I mean, I've been to the National Space Centre, very much enjoyed it. It's planned to spend an hour there when my son was young, and we ended up there the entire day. So it is very good, and I would highly recommend it. But what sort of initiatives are you using to reach kind of or to somehow appeal to the hard-to-reach communities? And the second bit, because we can hear about all sorts of initiatives, how are you measuring their impact and success?
Yeah. Yes, thank you. Hard to reach, how do we define? We go into prisons. We have a programme at the moment funded by the Esme Fairbairn Foundation for excluded children, for alternative provision. I'm going to answer some of your questions in instalments here as well, because you're talking about investment. There's a huge role here for universities to play, because as we agree, there's only one Maggie, she'll say otherwise. But there are lots of other role models who are coming through the university system. We employ them as during weekends and holidays and in the community. science explainers, as communicators who we can take out into these communities. They might be coming through first or second year science or space related courses, actually really relevant to students who are a few years younger than them, because they can talk about their very recent experience. So we've got some fantastic people, again, across the Science and Discovery Centre network, who are working in science centres, but actually from the universities, from further education colleges as well, who are capable. They're not Maggie, but they are brilliant and they are great, and they are doing that job of standing on stage or working one-to-one with students as well. And just being a brilliant teacher for them and getting to know them, because often as not, it's the cultural references they have. Is space science, astronomy being talked about in the family setup, for example? How can we bring the adults in, the parents in, or the guardians in, who, as I said earlier, they might have very little confidence in their own ability, but you want them to help push. Teachers as well, you might get teachers or you might get community leaders who are brilliant at encouraging the kids when we're not there to turn up. And how we measure success, if you're in a community and someone comes back half a dozen times, we tend to give incentives. Come once a week for 6 weeks and you get a ticket to the National Space Centre where you can come and show off the work you've done in those 6 weeks to your parents. They come along as well. There are prizes, all sorts of things. We've now got, I can tell you, 26 students who have been more than 20 times to one of our current community initiatives. They come every week. And they're so keen, and then you can start saying, well, what do you think about courses, course options at school? Would you think about, a space engineering program, or we've got a parallel immersive design course going on with Leicester College, so there's an arts and a science course that's going on, and offering this breadth of provision, which is not kind of the frightening academic route necessarily, but keeping them in this really engaging context of space, science, astronomy, and allowing them to express themselves through it. For the younger children, interestingly, we talked earlier about sport, dance. We've used sport and physics. We've used dance and physics. A lot of provision when we talk about hard to reach for those who might have hearing, sight, physical impairment. Neurodiversity is a big thing. Accessible afternoons, closing the place to everybody else and just make sure it's nice and quiet for a small number of people. So there's all sorts of different requirements out there. But I'd come back to role models. Maggie at the top of the iceberg, but I promise you there are lots of others. And there is a huge female bias. I would also say a huge female bias in astronomy. You
said something that I thought was quite important, and it said you said they get to know the young people they're working with. I was a physics teacher, and I had people coming in and out. They would come in and out of schools, but often it was a one-off, and one-off doesn't have impact. Building relationships has an impact, but often the organisations that were doing that were not actually taking the time and effort. It was a tick box to say, yes, we've done school engagement, yeah, but is there any impact, would be my question to that. You've talked about the local area, Leicester, and like I say, I've visited, I was really impressed. How do you widen that out across the UK to make sure it's not just young people in Leicester that are benefiting from the National Space Centre?
Yeah, so you asked for 3 bits of funding. The third request is a continuation of the UK Space Agency's Space for All Fund. It's run over 5 terms at the moment, 45,000 children in disadvantaged communities across the UK. So the UK Space Agency pays us to run the National Space Academy Space to Learn programme. We pay schools across the country to release, I think it's about 36 teachers for 25 days a year to go into schools in their territories and to deliver really intensive programmes at GCSE. And it's actually starting a bit younger at this stage. It's I think it starts at 13. But working through intensive, trying to get the repeat, because as I say, if you get to them, that makes it easier. There was a top-up fund to cover travel and meals, which was dissuading some from coming. If you're talking about barriers, you can provide the free provision, but if they can't get to the venue, and when we talk about venues, sometimes it's into schools, sometimes in the network going to Glasgow Science Centre, Edinburgh Dynamic Earth, Aberdeen Science Centre, where we've got a space camp and a careers conference coming up in the summer. Going to these places and doing everything we possibly can to break down the barriers. So, as I say, meals, free transport, free provision. It's a £1.8 million fund from the UK Space Agency, and it
1.8
million, and it for 45,000 students. It finishes in May 2025, and it is our dearest wish that that continues, because it's oversubscribed. If there wasn't public funding for it, we would have to either charge or find some other funding, and it's just working so well at the moment that I would love it to continue and grow, because 36 teachers can become 72 teachers, can become so many more. And wherever the model works, we've delivered it in the flats in Cape Town, we've delivered it in China, we've delivered it in the UAE, less financial problems there, but in Cape Town, around the flats there, absolutely fantastic over 3 years, because it was a programme that simply worked. And yes, the curriculum was based on UK, but it's not much of a change to tweak.
Thank you. I'm aware we're a bit tight for time, but thank you, and I'm sure that appeal has been heard loud and clear there. So thank you very much for that. Thank you
very much, Scout. Just a few kind of final questions from me. The committee in the last Parliament, in which Carol and Stephen and Graham sat, was critical of the STFC, the Funding Council's outreach activities. And what the committee found was that they had withdrawn some funding for outreach and public engagement to kind of concentrate on research, narrowly defined. Now, given the importance of building a pipeline of future talent, is that still the case? Could you update us, and do you have concerns about that?
Yes. First of all, I need to clear, I sat on the council for the STFC for a number of years, and from my understanding, in the past, one of the things that was really critical was when a grant was given, a certain amount was allocated, and this is what Chris Lintott was speaking about, was allocated for science communications. Having sat on the STFC and sort of seen sort of the flat rate and the challenges faced with juggling what science to fund, I can understand where the challenges are coming from. And I think there has been a reduction in outreach work, mainly because of these sort of challenges. They do some, and they're very effective. And in fact, when I go out to schools, I do direct schools to funding available from STFC in terms of space and astronomy and the other things they cover as well. But I think there is a pinch point. And I think research, it's quite interesting, because over the years I've seen, sort of worked with STFC and PPOC and in its many different guises, receiving money from them in terms of sort of media fellowships, but also sitting on the council. And you see the squeezing and the juggling of, okay, we will concentrate our research here and let some other research go. So it's not surprising that science communication is being pinched as well. But I think that is a challenge for us all in the future. If we don't have that pipeline, if we don't have the next generation coming through, we're all stuck. So I understand where the challenges are coming from, but I think it's something that definitely needs to be addressed.
Thank you. Then just reflecting on your experience in three, I guess, related sectors in which you've made a huge impact. One is obviously academia itself. Secondly, as you said, you've started up a company and launched it and spun it out. And then, of course, in the media. In looking at those three fields in which you've been active and thinking about diversity and inclusion, which do you think does it better?
Ooh. Interesting. So it does it better in terms of outreach?
In terms of success, I guess, of empowering and bringing in people from a wider background than has been the case traditionally in all of these areas.
Yes. So I think working with the media has the greatest reach. And that's one of the reasons I like working, and sort of when I say media, sort of television, radio, but also books and sort of TikTok, other things as well, because you're reaching audiences you wouldn't otherwise reach. Through the science communication, I fund my school's outreach through doing sort of commercial outreach. So I go and speak to bankers and lawyers and things like that, and then I'm able to go to most schools for free. So that is sort of quite an effective scenario. But of course, when you're going out to schools, I've seen sort of 500,000 people, and I'm knackered. But it is limited at the range, and CPD as well is very powerful, as you were just saying, because it empowers the teachers to go out. So I think the media is, in terms of my vision of a PR campaign, I think the media is the way to do it in many different guises. Also, it's the messages you send. We want to sort of talk about diversity. We want to be more inclusive. One of the things I like to try and get across is astronomy. When I was growing up, I thought that astronomy was done by white guys in togas. It was the Greeks, it was the Romans, that's all I ever heard about. And so telling a different tale where astronomy is done by people across the world. Every culture has looked up at the night sky and wondered. And so getting that message out there, I think, is very empowering for people to think, well, my ancestors did it, why can't I do it? Because at the moment, it is the white guys in togas that are winning. And so people think, well, that's just not for me.
Thank you. And just finally, in terms of the internal culture within astronomy, I was rather surprised in the evidence, the written evidence that we've taken, as to reports of bullying and harassment being particularly prevalent in astronomy. And there was a report by Professor Wyn Evans, Professor of Astrophysics at the University of Cambridge, who said in a survey of 650 astronomers, 44% had suffered bullying and harassment in the workplace within the preceding 12 months. And he said that bullies in astronomy are a feature, not a bug. That was rather surprising to me. It wouldn't have occurred to me as this was an environment that you would have expected to be one rife with bullying. Do you recognise that? Is that your experience from your career in astronomy?
From my experience, no. I am surprised, and also I'd like to categorise, because I'd like to see the report in more detail, because I think in academia is cutthroat and very competitive, and I think that leads to sort of that sort of environment where bullying and sort of, which is unfortunate and shouldn't be the case, but I think that sort of that pushing against the envelope can lead to that. I personally would have thought that astronomy would be less inclined to that. And so that does surprise me. And so I would like to compare it with other areas.
Why would you think astronomy would be less subject to
I don't know. I'm making generalisations here. I'm going off piece. I don't know. I think astronomy, when you look up at the night sky, it gives you a slightly different perspective. And this is anecdotal, and so I probably wouldn't stand up to peer review. But I do think working as an astronomer, and also going and working with the sky at night, speak to many sort of different astronomers, go to universities across the UK and abroad as well. And I don't know, astronomers generally, I think we my feeling is we like to support each other. I am an optimist. I see things through rose-tinted spectacles, so perhaps that's the perspective that's coming through. And so that's why I would like to compare it with other areas of STEM, because I would have thought that astronomy would be better than most.
Very sensible, Stephen. We'll do that when we carry out the research for our report. Can I thank Dame Maggie and Mr. Bishop for your evidence today. To all of our witnesses, that concludes this meeting of the committee. Order.
The proceeding has ended. The proceeding has ended. The proceeding has ended. The proceeding has ended.